All right, everybody. So, hey, so I'm recording now. We're gonna do, we're gonna start Unit 9 is inheritance, and then the last unit after that is Unit 10, recursion. Recursion is when a method calls itself, uh, and there's certain algorithms that recursion helps us do that are amazing. So today we're going to do notes, then we have a practice Google form, and then we're going to write a tree frog class. So yeah, let's do this. Pretty substantial notes today. I would stop talking amongst yourselves and be quiet and look up here because you're not going to know what's going on if you don't pay attention. So unit 9 is called inheritance, and 9.1 we're talking about superclasses and subclasses. So hey, with humans and other biological creatures, inheritance has to do with traits that offspring receive from their parents, like eye color and hair color and inability to be quiet during lectures. In Java, we use inheritance to build a hierarchy of classes that have similar characteristics. And let's say, for example, we have a book class, like we just wrote. It has these attributes, title and author. But later, can you guys be quiet back there, please? Later, we start working with graphic novels. So we have to add another attribute, right? Illustrator might not be the same person as the author. Now, we could just add an illustrator to the book class, but then we'd have to also add it to the book constructor and the book toString and everything else. You know, we'd have to think, oh, how do I put this new variable into this class? And granted, our book class was 8 lines of code, so no big deal. But let's imagine you had a more complicated project and you had to add a variable. Instead of adding the variable into the book class, we can make a new class and say it extends the book class, and we're calling it a graphic novel. So I'll show you. We actually literally use the word extend, and you'll see in a second. And that tells Java, hey, this new class is a child or a subclass of a parent or a superclass. And graphic novel automatically gets all the attributes, methods, functionality of a book, but it also has this new attribute, illustrator. And we call the book class the parent class or the superclass. And we call graphic novel the child class or the subclass. And I think I even show you, yeah, here we go. So public class book, private string title, we just wrote this, right? Book is the superclass. And then in another file or farther down in the REPL, we could say public class graphic novel extends book. It literally, this is how you write it. You have to say it right there. And that tells Java, hey, this thing extends the book class. And then we'd have right there the new variable we have, and then there'd be code to set the variable and print the variable and stuff like that. We're not going to worry about all that stuff today, but we're talking about hierarchy. Good so far? You can see how a graphic novel might live below a book. Yes. Yeah, yeah. Yep. So a graphic novel would have a title and an author, publication date, or any other variables we wanted, but only graphic novel would have the illustrator attribute because regular book in this world doesn't have pictures. So, why do we do this? Inheritance helps us reduce repeated code. It'd be kind of a pain if you had to make a new class. What if you just did a save as of book and called it graphic novel and then added illustrator, and then you added it, and then you added illustrator everywhere? That'd be kind of a hassle. Partly because if you then found a bug in your book class, you'd have to go fix it in the book class, and you'd have to go fix it in the graphic novel class. And then what if you had 13 other kinds of books, and you were having to make this change in 13, 15 places now? What a pain. Inheritance can improve code, readability, and your organization. And like I just said, inheritance can make it easier to maintain your code. So Anytime you have the same code happening, even in one class, you have the same thing happening in a bunch of places, it's probably better to write a method that does it once and call it from each place just once so that the code is in just a single place. Anyway, inheritance helps us do that. So the AP Classroom Unit 9 videos, which you're able to go online and watch anytime, they have an example. This is one I took from there. There's a bunch of people who are performers. So we're talking about musicians, comedians, dancers, and ballet dancers. And all these performers have a name, age, hometown, and they can all practice and perform. Okay? Specific types of performers have other attributes and abilities. So they gave me a slide. This is how Java portrays a class hierarchy. And the arrow direction is important. The arrow points to the superclass. So all these things, musician, comedian, dancer, ballet dancer, they're all performers. And there's a little bit farther down on the dancer side, but you would say a musician is a performer, a comedian is a performer, a dancer is a performer, and you could say a ballet dancer is a performer, or a ballet dancer is a dancer. Yes?
So would you say like ballet dancer extends dancer?
Yeah, in this case, it's double extension. Yep. When it's drawn like this, it means dancer extends performer, ballet dancer extends dancer. Let's see what else it says. Yeah, here we go. Everything I just said. Musician is a subclass of the performer superclass. Yep. How do we know which way the arrows go? Yes.
If you have like if each dancer had like a number and you perform a number, if you had a get number call in the performer class, would that still work?
It'd work for all of them. Yeah, it's pretty awesome. Yeah, he asked if there was a method in the performer class, like a ID number, or it said their hometown and their age. Yeah, you could get age from any of them, even 120 levels down. Yeah.
So like what we've done in the past, we did like a static variable.
Yeah.
Would that still apply to the other ones too? So like
that's a great question.
Like you made a musician, that's like.
Would a static variable apply to all of them? If it was up in the top class, I think it would apply to all of them. Yeah. I haven't tested that, but it makes sense that it would. So folks, the way we know which way the arrows go, because it's tempting, and I will admit the first year I taught this, I put the arrows in the wrong direction. But there's one in every crowd. One of my students is like, "Jay, you do the arrows wrong." I'm like, whoops. Anyway, I was like, thanks, and then I fixed it. So the arrow goes to the superclass. So and the way you can tell which way to go, or if it even is a hierarchy, is to say, you can say out loud, a musician is a performer. That makes sense. A comedian is a performer. Now, if somebody said a performer is a comedian, that's not always true. I mean, sure, a performer could be a comedian, but it's not always. So you wouldn't say a performer is a comedian and draw the arrow from performer to comedian. Here's a practice problem from the AP Classroom video. We got a school system. There's two types of people, students and teachers. Both types have name, age, address, ID number. Students, though, also have grade level and GPA, and teachers have a hire date and a salary. So which would be the best class design for this? So let's read this for a sec. And don't blurt out the answer. Okay, great.
B, use of a person superclass, and then choose
What is B? No, the answer is what is B? No, yeah, no, no, it's good. I don't know how to play that game. No. Yeah, a person superclass and 2 subclasses, student and teacher. Um, uh, and this is, we'll do it a little faster. This is another one from the video. That's the dude from the video. Thanks, dude, from the video. Look at this hierarchy. We've got lunch item. Under lunch item is like a drink family, but also a sandwich family. So, true or false, folks? A sandwich is a lunch item. I think that's true. A drink is a soda. I was trying to trick you, but you're too good. A hamburger is a lunch item. Yeah, even though it isn't directly, it's under that side of the tree. A tea is a drink. True. A soda is a tea. I smoke crack. True. Yeah, no, a soda is not a tea. They're next to each other in the hierarchy. I don't smoke crack, by the way. I've never have.
We got one video saying that
it was never proven. The accusations were dropped. Folks, a hot dog is a sandwich. I think so. By this ridiculous metric, not by reality. A hot dog is. Okay. We can argue about the validity of that statement. A lunch item is a sub. Yeah, it's the other way around. A sub is a lunch item. And a double hamburger is a lunch item. Yep. Good. Now, it's going to get a tiny bit trickier, and I want you to literally sketch this out on a piece of paper. So get out a piece of paper. Take a minute and sketch out a class hierarchy for this. Literally, on a piece of paper. Zoo, snake, bear, animal, polar bear, brown bear. Piece of paper, 6 things, put them in a hierarchy. Let me say, it's also possible that one of these items or more should not be in the hierarchy. Just because we're doing hierarchies doesn't mean we have to shove everything into the hierarchy. Hold up your picture so I can see it. I'm in business, folks. Put your pictures down.
Now we will grade us on our Readability, and that will be our.
In a way, folks, this was a trick question. Most people want to put zoo at the top, but would this be a true statement? An animal is a zoo? No. A zoo can have animals associated with it. Like, let's say, what if we had a zoo class and it had an array list, and we put all the animals in the array list? Boom. That'd be awesome. In fact, we should do that later. Not today, but another day. But animal, that seems like the top of this little hierarchy. And snake is an animal, bear is an animal, and then we got polar bear and brown bear are both bears. So this is what I would have done. And I'm proud of you if that's what you did. It's okay. I forgive you if you put zoo at the top.
I did it.
Yeah, it's okay, man. We've all been there. Yeah, get out.
Who said that?
Yeah, we've all been there.
You are not forgiven.
Folks, would this be a valid class header?
Yes.
Class snake extends animal.
Yes. Yes. Because animal is the.
That's what this is. Snake extends animal. It would be true to say a snake is an animal. Would it be true to say this? Class brown bear extends animal. And you guys are wise to my tricks, because the brown bear is an animal, but it doesn't extend animal. It extends bear. Sure, a brown bear is an animal, but in the hierarchy extends bear, not animal. How about this? Class brown bear extends bear.
Amen.
Say it again. It's awesome.
Brown bear is a bear.
Let's go back to our performers. And in fact, we're going to zoom in on a performer and a comedian. Performer Paul equals new performer. And look, this is all the stuff that performer has. These are the variables: name, age, hometown, agent. And then get name, get age, get hometown, get agent. These are accessor methods. Practice is just some sort of other active method. Perform and toString would let you print it. A comedian extends a performer, so it has access to all that stuff, but it also has a jokes variable and a write jokes method. So it would be legit, I'm telling you. You could, in Java, say performer Paul equals new performer, comedian Chris equals new comedian. All right. Now, I've got 4 calls down below. We're going to walk through them one at a time and say which one would be legit. So could you say Chris.getAgent?
Yes.
So getAgent is right here. Chris is a comedian, but remember, comedians have access to all the methods and all the public methods in Performer. Chris practice. Chris.practice. Yep. Paul.perform. I'm jumping ahead. And Paul.write jokes.
Absolutely not. Disgusting.
Nope, because Paul's the performer. Paul can't get down into the comedian class and start writing jokes. It would not be funny, and it would not be legal.
Then he would be arrested.
Paul.
Rise up against him and kill.
Wow. It looks like that's the end of my slide deck. I really wanted to keep going. But 35 slides probably was enough for today.
We all
Here I am.